Alright, this is lesson 1.1 of our geometry class. And this lesson is just going to really talk about the building blocks of geometry. And, what is geometry? Geometry is like the study of the physical world, like measurements in the physical world. Right? So getting right into it, there are some building blocks of geometry, and you need to be able to recognize how those building blocks are used and how we use symbols to represent those building blocks of geometry. And the most basic building block of geometry is a point. Okay, a point is just like in algebra. It's just like a something that identifies a location. It identifies a location in space. In any space, whether that space is our classroom, your house, right? And points have no dimensions. All right, now what is a dimension? All right, a dimension is like a length or a width or a height. And depending on, your perspective of it, this could be a length, that could be a length, this could be a length, or it's a height, right? Whatever, right? We live in a three-dimensional world, right? Where we have lengths, widths, and heights. Points don't have any of those. They're just a point. They don't have any measurable significance. Okay, so a point is designated with usually like a letter or something. Like this would be point P. All right, that's point P. All right. So now next thing we have, if we have multiple points, right, you kind of have to recognize that they are in relationship to each other. Well, if we have points, we can make one line through those points, because right now we have a point and we can draw a single line through that point from any direction. It can go from this way, from that way, from this way. It can come from up and go in, right? That point doesn't really give us any useful information. But if I have another point, right, I can make a line. Okay, and a line define the relationships between these 2 points in 2 dimensions, or correction, one dimension. Right, so if I have this point, I'll call that point P, and I have another point over here, I'll call that point, I don't know, B, right? I can have a line that goes through those 2 points. Whoops, that didn't work out great. But like this, and that is what that line looks like. Okay, and I'm going to represent that line with symbols using this PB. Okay, now although this is in one dimension, we'll call this the width, and we'll call this line L, right? Either way, it's only going in one direction, left to right, and it goes infinitely long this way, in that direction, and infinite in that direction. Lines, although they're in one dimension, they continue forever to negative infinity and positive infinity, respectively. Or maybe this is positive infinity and maybe this is negative infinity. It really depends upon our frame of reference. But the point is moot, they go on forever. Okay? But if I bound this line, I say, okay, well, this line starts at point P. This is a line. This point starts at point P, and it goes forever, only in one direction. It's still one-dimensional, right? And this is now called a ray. Right? Think about it like a little Martian here with a little ray gun. That's my ray gun. Right? That's a ray, and that's my Martian. Okay, that's my array gun, and this is point P, and this is point B. This is ray PB, and identify that it's a ray. It goes that way. Now this could be called line BP or line B or ray BP. It doesn't really matter, but it makes more sense to me to go from left to right in this particular case. Okay, now if I want to, this is still infinitely long, right? Because it goes on infinitely long forever that way, even though it has a starting point. It's still, infinity is infinity. Okay, this is array. Okay, and then finally, what we're going to be using most of the time are segments. And this is like if I start at P and I end at B, this is a line segment. It's not a very straight line segment. And this is a line segment PB. Now, this is still one-dimensional, right? But it is measurable. In this case, it's based upon these random squares that are at a random height and width, right? It says 1, 2, 3, 4, 5, 6, 7 units long. Now, these units, these things could represent miles, they could represent kilometers, they could represent feet, right? It could represent inches, whatever, right? But this is line segment PB. Something like that. We don't have any arrows on the edge of any of these things. Okay, so that's line segment PB. And this is 8 units long. I think it's kind of 1, 2, 3, 4, 5, 6, 7 units long. 7 units. Okay, now if I wanted to be specific, this is 7 units raised to the first power. All right, now keep that in mind for the future. Okay, if the exponent is 1, it's just left blank. It is one-dimensional. Okay, we're gonna circle back to that here in a little bit. Okay, now if I take 2 lines or 2 rays or 2 line segments or a combination of these things, and I have one, say, going this way, right? And then I have another one. This is a line that goes like this, and I'll call this line MN, right? And then I have a ray coming off like that, right? We'll call this line, we'll call this point P, we'll call this point Z, and this is ray PZ, right? This ray intersects MN at point P. Okay, and it makes angles, right? 2 different angles. All right, so an angle is formed by intersecting lines, rays, or segments. Okay, we're going to get into angles a little bit more in lesson 1.2. Okay, so there are other types of lines or different characteristics of lines we're going to get into a little bit later. But I guess I'll go on to 2 dimensions now. Right, 2 dimensions, which is like this piece of paper. It exists in 2 dimensions. It has a left up and down and a left and a right. Or this card. Right, this card it's a plane segment, right? Because a plane is made up of an infinite amount of lines, right? Now we have a plane, and it has a length and a width. Okay, and planes, right? It goes on forever. Like if it has a bunch of like squares on it, and I can kind of like pull up coordinates. That's called a coordinate plane, and you probably should be pretty familiar with that. But a plane is generally shown like something like that. Okay, and this isn't actually a plane. This is a segment of a plane. If I said it went like that forever, went like that forever, went like that forever, went like that forever, that way forever, that way forever, and that way forever, right? Yeah, it's a plane. We'll call this plane P. Right? And segments of that plane have area. Okay? It has a length and a width. So say, for instance, I had a plane made up of 4 intersecting lines, and they all came up at a 90-degree angle. Right, you guys are probably familiar with 90-degree angles. That's something like a square, especially if these line lengths are all the same size. Okay, let's say that this was 1, 2, 3, 4, 5. Okay, and this is 1, 2, 3, 4, 5. All right, so this is a 5 by 5 unit portion of a plane. Okay, so this is 25 units squared because it's 2-dimensional. 2 dimensions, right? So planes are in 2 dimensions because they use a length and a width, or a width and a height, or a, what else do I have? A length and a height, right? Whatever they tend to be. Okay, so those are the building blocks: lines, planes, angles. And we didn't talk about arcs, but arcs are like curved lines, right? But that's going to come later on in the course. For the most part, the first 10 units or so are all going to be concerning straight lines by and large. Okay, so that's lesson 1.1. That's all the building blocks of geometry, and I hope that this helps you define some things when we're talking about lines, planes, points, and the different types of rays, lines, segments, and stuff like that.